centralize all the logic and the data on one piece. Who was what? An internet server. And the dummy terminal was just a browser. Of course, we saw that there was some kind of limitations with that. So once again, we decentralized the logic, but in a more efficient way as before, as client server, by decoupling the logic in 3 tiers. One was on the browser, one was on what we call an application server, one was in a centralized, for the centralized data. And then we are now in yet another type of applications called distributed application, where we decouple totally the logic and the data. We distributed the logic in what we call microservices. Microservices can run anywhere in the world. It's usually linked to the cloud. So anywhere in the cloud, you can have microservices and your application can use those microservices. And this is the same for the data. The data can be given by APIs, or if you look at databases that are more adapted to the cloud infrastructure, like MongoDB, for instance, we are using there what we call the sharding, meaning we are using the entire cloud infrastructure to store the data. Of course, this shift is also a kind of balance of the responsibility between the business and the IT. When we were on the mainframe, all the responsibility of the business were given to the IT, who was like managing all accounting, all product management, and things like that. When personal computers arrived, it was a little bit different, because business people were able to have a computer and do things that people in IT were even not able to do. So they get a little bit of power, and this is how the personal computer really expanded. The client server was a shift back a little bit to IT because of the power of Ethernet, meaning being able to connect personal computers between each other. The IT said, now we're going to rethink about the architecture with a decentralized logic, but a centralized data, which is the most important. We need to protect data. And we were really into some kind of departmental applications, not yet enterprise class applications. And then became internet, who was like a way to showcase to the world what a company was able to do. So the business took back the responsibility of that. But once again, reached some limitations. And then the IT went back with a Web 2.0 architecture with a 3-tier decoupled logic. And now with the cloud, it's a little bit different. A lot of SaaS offers are able to are there to help business also to do as much as they can by themselves. But we can see that it has some limitations because of the consumption that you can reach. So it's back to the IT now to find the right logic. And you'll see, we'll talk about the story about of Netflix. You'll see that it is exactly what happened there. Sorry. So why do we need that kind of architecture? It needs to be adapted to the current kind of consumption that we can have. The scalability is very important. We have, for any application that is available on internet today, a very high volume of consumers and devices. When I say very high, it's like you can reach the entire world, you know? Let's say you have a shop before and the shop was in a street. You can reach the people coming in the street. But now if you do your business totally digitalized on internet, you can reach the entire world, different languages, different number of people who can access that. The problem is that the network, the cloud, is totally unreliable. And every time you have a downtime, it has a dramatic impact. I recently went for vacation to France. I'm French. I live in the US, but I went to France for vacation. And when I arrived at the airport, I went to rent my car. I won't name the company, but they were unable to do any contract. Their entire system was totally down. Believe me, it was dramatic for everyone because the customer experience was really, really bad. It has to be adaptive to rapid changes. The business is progressing in a way that every day there is a potential new way to do business, new partnerships, and this needs to adapt the architecture. You need probably, because of a partnership, to reach new APIs and embed those APIs into your application. You don't have six months to do it as before. You have to do it for yesterday. This is what the business is going to ask. Also, to make sure that your application is not in a blocking situation because of the consumption, it is better to be event-driven kind of application, meaning like with a PubSub system, execution system, you can, when there is a request, you can put the request in a queue, and then the queue is gonna pile all the requests and execute the request as much as possible. You need to rate limits as well. It's very important to make sure that if you open your application on internet, if there is a big consumption, and because you are paying for the infrastructure, you're not going to pay millions because of the success of your application. So that's also, you need a way in your application to make sure that you don't reach some kind of limits that can be difficult for your enterprise. And you need, of course, because the application is distributed, you need to make sure that you can back off something that didn't work, or retry, or run some compensation. There is a lot of business cases where it isn't, you're in a process, you execute your process, the process didn't go well. Instead of just staying and being locked on this failure, you switch to a compensation process. So all of this is really the why we really need something new today. Sorry. So there is really a need for distributed application, and understand that APIs are today really everywhere. Everywhere from an internal point of view, like your own APIs can be deployed everywhere, but also your application can be made of APIs that comes from everywhere, from partners, from clients, from public APIs, in order to validate an address or things like that. And this is really a modern way to develop applications by, instead of building everything in one container and put that container up, you're using systems like Kubernetes, who's going to manage your containers to do a consumption as needed and make sure that it scales appropriately. That will help you also to manage cost of the cloud infrastructure that you're using. A lot of people were at the beginning run very, very well to EC2 kind of proposal by AWS, and AWS itself realized that the bill for their own customers were too big, and that's why they came with some kind of in serverless architecture, step functions, or technical proposal like that will help developers to reduce the amount of money they have to pay for the cloud infrastructure to keep their own customers. Need to manage back pressures on individual services. This is kind of important, that if you have one service that is consumed heavily, to make sure it's exactly like plumbing. If you have like a pipe and a lot of water and too much water, you're going to have a back pressure. The water is going to go back. That can happen the same way on API. So it's very important to be sure to manage back pressure. And the kind of communication, you probably learn at school a lot about REST APIs through HTTP. There is a better way now to do all of those communication called RPC-based communication with open source called gRPC that has been provided by Google. So all of these are really the basis of a modern way to develop applications. But what means distributed, scalable distributed applications? It means that you cannot just develop your APIs, develop your service, and deploy your service. You need to orchestrate the execution of those services and to make sure that the orchestration is not embedded into all of the services. You need to make sure that the logic of routing between services is externalized from the services themselves. And this is in what we call a workflow today. As you see in this example, it's a subscription. You can go through a trial, and the trial will send you a notification. And then after the trial period, you're going to go in a monthly charge. You can cancel your subscription at any time. This is a kind of orchestration that implies a lot of different services and make them work together nicely. You can be adaptive to rapid changes, because a change can be another routing, not necessarily a new services to build. So that's interesting to have this orchestration decoupled from the services themselves. You can also schedule the execution of the orchestration. This is something orchestration platform are offering, and we'll see this is one of the feature that Conductor is providing. Another item quite important is what we call observability. Observability is totally different than orchestration. Orchestration is really on execution of the logic, the routing between microservices with different possibility, like conditional execution, parallel executions, loops, things like that. Observability is really introspection of the execution of one service to see if everything goes well. And if it doesn't go well, we need to identify where was the problem. An orchestration platform can give you that in seconds. You don't have to look at code. The first thing, you look at the visual orchestration that is provided, and you can identify just by looking which one was in red. So you can say, oh, my problem was there. And then you click on the service that is implied, and you can see the log of that service, and you can point exactly where was the problem. It's also important for documentation, because if you build a project and then you move to another project, someone else is taking your project, if you go and look at the orchestration, you will understand the way your application is working. So very important for documentation. Developers usually don't like to write documentation. By putting the application as an orchestration, it improves and gives you out of the box the documentation of how the application is working. So what is Netflix Conductor? A little bit about the story. We used to say Conductor is built at Netflix and maintained by Orkes. The story is that at one point, it was very important for Netflix to understand what is working. They are investing a lot of money into some movies or TV shows. They need to know right away what is working, what is not working. And for that, the application, if you go to your homepage at Netflix, you can see a lot of content that is provided based on your own experience, what you like, what you don't like, what you watched, what you did not, what others did. Others who watch this, they also watch something else. So all of those things are going to be proposed to you. And there is a kind of ranking. All the content that you see on your homepage is built using Conductor. And they needed something that really can scale. So instead of creating an app that can try to scale, Netflix decided to create a system. And the system has been, after that, put as an open source. So everyone can use it today. The creators of Conductors left Netflix, and when they created Orkes, they took the product and put enterprise class services and build an enterprise version of Conductor. Enterprise class services means security features for access control, a better scheduler than the one that is that was built at Conductor, because Netflix has a total different to manage security and manage scheduling. So we thought that it would be good to provide something a little bit different as an enterprise version. And Conductor is used today by thousands of organizations. You have a list of those organizations that is on this slide. You can see that it's different industries. You have like people that are in financial services. You have people in logistics. You have people in media, of course. You have people in auto, like Tesla. Tesla is probably one of the most important. So what is Orkes Conductor? Orkes Conductor is an enterprise class orchestration platform. It is provided as a SaaS, meaning like you go on cloud.orkes.io and you can create your cluster. You can deploy Conductor in that cluster. That would help you to build your application out of the box here. We have also security access control. I talked about it. Enhanced user interface. You'll see in the next session. That would be not the next, but the one after the next. The next session will show as well how to use it. That will be kind of interesting. You have an example here on the slide. What means the UI that we're providing. We have also adding some plugins like artificial intelligence capabilities, and of course support. There is a playground for developers for the hackathon. I would recommend to go to the playground. You can go on play.orkes.io and register an account there, or you can just scan this QR code. What is a distributed apps with Conductor? It's based on three main things. One is workflow, the workflow itself, where you will define the application state, define routing and orchestration across services, and manage distributed transactional backend. We have the workers. Workers are individual tasks of a workflow, totally stateless components. And the beauty of it is it's language agnostic, meaning that you can write a worker in Java, in Go, in Python, in C#, even in Clojure or JavaScript. And we are adding more and more support for other languages also, like Rust, for example, that is on the pipeline. Your workers runs and scales on Kubernetes, on VMs, wherever. It can run also on your own laptop. So you can use the playground, have an orchestration there that will call directly a worker that will run on your laptop. This is sometimes the way we are developing. And the application itself means what? Means like a list of workflows that can be accessed by APIs to start and execute the workflows. or it can be webhooks, can be linked to some event system like Kafka as well. So when there is an event, automatically the workflow is executed. All right, we are at the end of the session. Still a little bit of time for Q&A if you have.
Right. Olivia, I see one question. I'm not sure who's asked this, but the name is not mentioned. It's a very interesting question, and the person's asking how can they get started to learn more around Conductor and also contribute to
Of course.
Conductor.
So again, there are two ways. The best way to start with Conductor and see the product is to go to play.orkes.io. And then you register and you have access to the entire Conductor there. So you can create your orchestration. You can see some other examples as well and be inspired from what others on the playground did. The second way when you have that is to go to the open source GitHub repository. And I think Sangeeta is going to put it in the Q&A section as well. It's GitHub/Netflix/Conductor, and you can have access to the entire product there, the source code of the product. You can fork it, which is not really recommended. You can download and install on your own infrastructure. And there is a contribution procedure that is explained there. Of course, Orkes is the sole maintainer of Conductor. So when you provide, you can do a pull request, send your pull request. It will be reviewed by the maintainers. Probably they will ask some changes to make sure that the code corresponds to what is there, and then they will be happy to validate your PR. Just by a little information, we have a lot of people that are contributing on every version of the product. The last one had 4 new contributors, for example. So yeah, you can contribute, of course, and this is what the community is already doing. It's a lot of different contributions because people have different ideas, different needs. Of course, this is what we think is best. So we're going to put it as new features, but a lot of new features are also coming from the community itself. So we encourage everyone to do it.
Right. Thank you so much for sharing that, Olivier. I think we are almost towards the end of the session. Because they are students, I think it'd be really, really interesting to know that after college, if they're working, say if they continue to contribute to Conductor and work on microservices, what kind of job roles can they get into?
Well, the good thing is that orchestration with a product like Conductor touches a lot of different departments in engineering. It can be core engineering, it can be the people building applications, it can be also people that are more in DevOps to orchestrate all the pipeline of deploying applications. It can be SREs, it can be so you have a broad list of different jobs that you can do just by learning how to do this kind of orchestration. A lot of tools and solutions are provided as microservices today. Being able to do an orchestration of those microservices will help you in many different jobs.
Right. Thank you so much for sharing that.
I was, just as an example, I was with a big bank yesterday in a call. There were 2 teams that usually, are not working totally together, but they were there with their own needs, with the same product.
Amazing. We have another question. I cannot see the name of the person who's put it up, but the person's asking that can we say Orkes is open source? And is it possible for us to connect with people who are contributing to Conductor, it would be super amazing to learn from them.
You're going to be connected to them by doing this hackathon for sure, because they will be connected, and one of the session will be from the people that are in the engineering team. It is so there is no problem for that. Orkes Conductor is not open source, but Conductor itself is open source, and the Orkes engineering team is contributing and maintaining the open source. So we're going to open soon a Slack channel as well, where you can go. You can already register to it. Actually, if you go to orkes.io, there is a Slack channel there, and you can just access it. All the engineers and developers of Conductor are there, and they can respond to any of your questions.
Right. Just one last question that I see from Sanskriti, and she's asking that are any prerequisites required for integrating Conductor for the hackathon projects? Also, how fast can they set it up?
That's a very interesting question, because it helped me to tell you one of the best feature of the product. It is non-intrusive. A lot of people are using Conductor just to start a migration of their digital platform. So they have a monolithic application, and they say, we're going to externalize that part. We're going to create one orchestration that will execute a new service here, and that will execute also in the monolithic application. So it's pretty interesting how non-intrusive the product can be. How fast you can set it up? It's just a few lines of code in any of the language that I explain. We have SDKs for all of them. You can set it up pretty quickly by just, like, if you know Java and Spring for instance, it's just a few annotations and you have a worker.
Perfect. Awesome. Sanskriti, we'll have more sessions where you'll actually get to see how to, create your workflows on Conductor very soon. So stay tuned. I think that's all the questions that we had. We are already over time by 10 minutes. So yes, um, yeah, I think we are all excited to see everyone at the hackathon, and we are hoping to see you soon. And yeah, any last words, Oliver?
Thank you, Sangeeta. And yeah, good luck everyone for this challenge. And feel free to join us on Slack. We're going to put a dedicated channel for the hackathon. We are just setting this up right now. And yeah, any question about the product, reach out to us. No problem. Thanks, everyone.
Yes. Have a good day, everyone. Take care. Bye. Thank you so much for the session, Oliver.
Thank you, Sangeeta.